Hey everyone. Okay, so we're going to be working on those some natural logarithmic functions and their derivatives today. Um, so let's look at this one. So this is kind of still from that study guide. This is C. So this is kind of we're going to be working with the same kind of rules that would happen, and those are the logarithmic functions, those derivatives. So here's our first. Here's our function, the f of t. We have ln of 6 t to the fourth, like this long looking derivative. And so what I know these things could look a bit scary at first, but once you start getting the pattern down and the that because you see these things so often that like they have a certain pattern that you kind of start getting a little bit more used to. So hopefully we could start clearing some of this stuff up. But I understand how crazy some of this stuff looks because you have log and then you have all these variable. I mean, same variable, but just so much of it. And so what we want to do, so I'm going to say f prime, just for shorthand. This is still with respect to t. But we have everything is being taken to the first derivative, or just taking the derivative of. And so what we're going to do is that it always kind of has this pattern of whatever's on the inside, I'm going to keep down on the fraction. We're going to keep down in the fraction, and then what we're going to have on top is this same derivative. So let's see. Then we'll have hopefully have that derivative, and what we're going to do is get rid of that ln. So let's kind of get into it and look at it. So we know we're going to have this fraction, and so I'm going to keep these t's. Since I'm going to be writing so many of them, t to the 4 minus 3 to t to the 8th is 1.5 t to the okay. So that's kind of what we have. This is going to be orange. So that was what was inside of this ln. We're just going to keep that down in the bottom. This isn't another fraction. I was just kind of underlining everything. And now what we're going to do is we're going to have the derivative of what's in the inside. So the derivative of what was on the inside, which is going to be 6t to the 4th minus 3 over 2 t to the 8th minus 1.5 t. And I need to give myself a little bit more space. Plus 17.6. Now we're going to be taking the derivative of that. So it will always show this kind of pattern of what we have on the inside gets dropped down. And then what we have on top is the derivative of what was on the inside. So it's kind of coming from our chain rule in some ways. But for now, like, this is that pattern that we kind of get used to, is the derivative of what's on the inside over what was on the inside of that ln. Okay, so now what we're going to do is just take the derivative of what we have on top. And this is going to be a lot of power rules. This is a 15t, and this is going to be squared. Okay. The nice thing about this 17.6 is that it's going to go away when we take its derivative. I've kind of shown in some of the other videos the distributing of like, you know, for sum and products. Same thing's going on here, so I'm going to kind of just jump into what each of these derivatives are. Make sure to check out some of these other videos if you're struggling with, you know, those sum and difference rules for the derivatives. Okay, so because it's kind of just, we get to kind of distribute that derivative in a way. So this is going to be 24 t to the third, because that power of 6 is going to be, or that power of 4 is going to drop down. Multiply with 6, get 24, and we'll get 3 up top because we're losing a power. Now here's the nice thing about this one is that minus 3 halves, when I bring down this 8, that 8's going to get divided by this 2, which is going to really make it 4. So hopefully we could, wanted to show it, but I think the best way is to kind of get to it. So we're going to actually have 3 times 4, which is going to be 12. So minus 12t, and then we're going to have 7. If I bring 2 down, 2 times 1.5 is going to be 3. We're just going to have t, and then that's it. Because this goes to 0. Okay. That's going to be all over our original function. So, well, what was on the inside of our ln? So t to the 4th minus 3 halves t to the 8th minus 1.5 t squared plus 17.6. Okay, and that's our answer. There's no need to really, I don't think we could do anything else to this. So this is our f prime of t. Okay. See, these derivatives aren't too bad. It's just that pattern. It's that what was in the inside goes down to the bottom, and then we take the derivative of what was in the inside. So if you take these step by step, they, you know, could help. So I kind of want to focus in what I did here. So we have this negative, because I did that pretty quick. And sometimes it's good to kind of, for us to go over the algebra, because calculus is pretty algebra heavy. Okay, so if I said I'm taking the derivative of this, which we did, this is constant multiple. So I get to bring that negative 3, 2 down, or out. And then I'm really taking the derivative of this t to the 8th power, right? Okay, so with this, what I was kind of saying, and maybe it wasn't clear, and I kind of want to make sure that it is I'm bringing that power of 8 down, and then I'm left with 7 on top, right? So what I was saying is that this is going to be kind of like 3 times 8 over 2 of t to the 7th. You know, this all equal. Okay. So what I was saying is that I could actually reduce this 8. Hopefully this 2 cancels out. That 8 goes to 4. So this is what I was kind of saying, and it might have hopefully not confused people, but maybe it did, and I just want to make sure we could see what I was doing. So that's negative 3 times 4, 7, and then negative 3 times 4, negative 12t to the 7. So kind of what I was doing in my head was already reducing that fraction. And once you get used to it, once you do some of these problems over and over and over, you kind of get used to that look, and so that's what kind of occurred there, what happened there, and that's what we got again. So but that's good that we're able to continue to do this and come with the same results. Hopefully this was helpful for this. I'm going to be posting some more videos for some of these other derivatives. And we'll get into quotient rule and some of those things later. But luckily for this one, we don't have to use that. We're really using these ln properties. So again, we're going to have what was in the inside down on the bottom. We're going to just write that straight, which is nice. We're going to write exactly how it was. And then what we had on the inside is what we're going to have on top of this fraction, but we're going to be taking the derivative. And that 17.6, I know it kind of looks a little weird, but it is just a constant, and so it goes away. It doesn't matter how it looks. And in fact, I think even on the first one, we had this ln of, q root of 20, and that goes away because there's no variable in that. So, yeah, hopefully this was helpful for anybody who's kind of struggling with this. But, yeah. It's not too bad once you get used to the pattern, and remember, take them step by step. I think that's something that helped me out, at least in my personal experience. What really helped me out. Okay. Hopefully this was helpful. All right, thanks, guys.